All right, today we're taking a look at reflections. We have an objective here that was the same as with translations. I can verify that an object has been rotated, reflected, or translated by comparing the lengths of lines and line segments from one object to the other. Our first vocabulary term is a transformation where a figure is flipped over a line, also called a flip. That is a reflection. So literally, it's like, if you flip something over, when you start with something and then you flip it over, the pre-image to the image is what we're talking about today, that process of reflecting. The line over which a figure is reflected is called a line of reflection. Okay, it's different if I take my hand and I pick it straight up and flip it over, like that, or if I have it here and I flip it to over there. That's a different line of reflection, different mirror point, basically, that you flip that figure over. The triangle shown on the grid is a pre-image. You will explore reflections across the X and Y axes in this activity here. This activity we're going to do in class. It's too fun to not do in class. So we're going to wait and do this one together in class and explore a little more reflections then. But let's go ahead and slide down here and take a look at the steps for reflecting. It says the figure shows triangle XYZ. Graph the image of the triangle after reflection across the x-axis. So the x-axis right here is what it's called the line of reflection. So when we have our pre-image and our image, every point that we have on this triangle will be the same distance away, like y and y prime. It's 1 unit away this direction, so it's going to be 1 unit away that direction. So what you need to do, just like we would do with translations, is just do it one step at a time or 1 point at a time, and then from there you can build the image after you've put all the points where they're supposed to go. This is all already basically done for you. We know that we're reflecting across the x-axis right here. They said to start with reflecting point X. Point X is 3 units below the x-axis. See, 1, 2, 3. Count 3 units above the x-axis and plot point X prime. So if it's 3 units away this way, we go back to the line of reflection and we count 3 units that way, and that's where X prime will be. Reflect point Y. See, point Y is 1 unit below the y-axis, or excuse me, the x-axis. Count 1 unit above the x-axis and plot point Y prime. So if it's 1 unit this way, down, it's going to be 1 unit this way for the reflection. And then with point Z, it's 5 units down from the x-axis. It's going to be 5 units up from the x-axis when we reflect it. Now we just need to connect x prime, y prime, and z prime to form the triangle x prime, y prime, z prime. So now we just need to connect these points here, and we have made a reflection of that shape. So we just basically go 1 point at a time to create a reflection. All right, let's flip over to the back side here and take a look at some of these practice problems here. We're going to do a few of these. This says graph the image of the figure after using the given transformation. So this is going to be a reflection across the y-axis. And for some reason this one wasn't labeled. Let's go ahead and label these because usually it's good to have your vertices labeled. So we'll call this one A, we'll call this one B, and this one C. Okay, so go ahead and label that real quick. We're reflecting across the y-axis, so it's really important you pay attention to which one we're flipping over. And it's usually either going to be the x-axis or the y-axis. We're reflecting across the y-axis right here. And so we're just going to take 1 point at a time. If A is 2 units away this direction and we're reflecting over the y-axis, the A prime will be 2 units this way. So put a point there, label that A prime. B is just 1 unit away this way, so we're going to go 1 unit this way and label that B prime. C is 1, 2, 3 units from here, so we're going to go to the left 1, 2, 3. Put a point there, label that C prime. Then you just got to connect the dots. You have reflected your figure there, the pre-image to the image. Number 3, or skip number 2, we'll do that one in class. Number 3, it says reflect across the x-axis, but it doesn't have the figure there yet. So we have to graph it first, and then reflect it across the x-axis. So let's go ahead and put these points on here. We got -2, 1, be back 2 and up 1. Put a point there and label that A. We have negative 3, 1, so back 1, 2, 3, and up 1. Oh, it's going to be confusing where I put the A there, so let's move that. That right there. Right there is going to be B. And then negative 4, 5 for C. Back 1, 2, 3, 4, and up 1, 2, 3, 4, 5. Way up there. I'm going to call that one C. This is a little bit of a funny looking triangle here. I couldn't draw a straight line there. Let's try again. Alright, and then down here, and then across there. Okay, it says we're reflecting across the x-axis this time. This is the x-axis right here. So we're going to go the same distance away from each one of these points, from the line for each one of these points. So A was 1 unit away this way, go down 1 unit, and label that A prime. B was 1 unit up, we're going to go 1 unit down, be B prime. C, and we have to go straight up or straight down, so from here it's 1, 2, 3, 4, 5, so from here it's going to be down 1, 2, 3, 4, 5. We'll label that C prime. So now we're just going to connect these dots. There we go. And we will have reflected that figure there. Okay, just one point at a time. All right, this says find the coordinates of the vertices after each given transformation, and this time we're not given a picture, we're just given the coordinates. So this time we have to change it from A to A prime, from B to B prime, and from C to C prime. So let's talk a little bit about what happens with each one of these. We're going to do a reflection across the y-axis. Okay, the last time we did a reflection across the y-axis, we had this figure right here. So let's look at this for a minute. Let's analyze what happened here. And maybe that'll help us understand what we need to do if we're just working with the coordinates. So this one here, from A to A prime, the coordinates were, let's see, we were at 2, negative 1 for A. A prime is at negative 2, negative 1. Okay, interesting. B to B prime. Let's take a look at this. We have 1, negative 2, 1, negative 2, and then B prime was at negative 1, negative 2. Negative 1, negative 2. And then I guess we can do C here. C and C prime. We're just going to analyze these and see what we come up with here. C, original C is at 1, 2, 3, and down 1, 2, 3, so 3, negative 3. And then C prime is at negative 3, negative 3. So with each one of these, you notice that one of the coordinates stayed the same, and one of them changed to the opposite of what it was. So it looks like x changed from here from 2 to negative 2, from 1 to negative 1, and from 3 to negative 3. So it changed to the opposite of what it was, while the y coordinate stayed the same. So when we reflect across the y-axis, the y-coordinate is just going to stay the same. You can see these all stayed at the same level on y, right? So A was at negative 1, it stayed at negative 1. B was at negative 2, it stayed at negative 2. C was at negative 3, it stayed at negative 3. But it flipped, since it flipped over the y-axis, it changed where it was at on the x-axis here, right? So it was at A was at 2, flipped over, and changed to negative 2. So if we're going to apply that rule now to just coordinates, we know that when it flips over the y-axis, the y-coordinate actually stays the same, but the x-coordinate changes to its opposite. So 2 will change to negative 2, but the y will stay the same. This x will change from 3 to negative 3, but the y will stay the same. And for this one, the 4 will change to negative 4, but the y will stay the same. So when you flip over the y-axis, the coordinate stays the same. The y-coordinate stays the same. The x-coordinate changes to its opposite. All right, for number 7 here, it says write a rule to describe each transformation. These are pretty easy here because you're just looking to see which axis it flipped over. So we know that the rule is going to be a reflection. It's a reflection over the, okay, it looks like we flipped over this axis right here, which is the x-axis. So a reflection over the x-axis. All right, so that's it. You're going to have a little bit of work on this. We'll do a little more work in class. We'll talk a little bit more about the coordinates and all that, how that works together. But we'll see you guys then.